Hello again, welcome to Lesson 2, Evaluating Expressions and Combining Like Terms. Those are also our two learning targets, evaluate expressions. We'll talk about what the word evaluate means, and then combine like terms are our two learning targets today. And we're actually going to use the distributive property to combine like terms, talk a little bit about how that works. With today's lesson, we'll have to understand a couple of new concepts. First, an algebraic expression is an expression that contains numbers, variables, and operations. So expression is simply just a math language, a math version of a situation. So if maybe you had a lemonade stand growing up as a kid and you sold your lemonade for 25 cents per cup, well, you could represent your profit by taking 25 cents and timesing it by the number of cups that you sold. That would be your profit that you made on your lemonade stand. Next is a variable. Variables are any letters that represent one or more numbers. And evaluated, so there's that word evaluated from our learning target, is when you replace the variables with the numbers and simplify using the order of operations. So we will review the order of operations quick. So first thing you'll do in order of operations is anything inside parentheses or grouping symbols, which could also be brackets. Next, we will do any exponent. Thirdly, we'll do multiplication or division. We'll work left to right. So those are not done in that order per se. It's just you do whatever's on the left as you read it left to right through the problem. And same with adding or subtracting. We'll work left to right. And the acronym that can help us remember this is please excuse my dear Aunt Sally. So we can remember PEMDAS to help us remember the order that we're supposed to go for our order of operations. So we'll start by looking at evaluating an algebraic expression. And it tells us evaluate if x is -3 and y is -1. So we are first going to start out by taking -3, and we'll put that in for our x value. -1, we'll put that in for our y value. So I have now replaced x and y with their equivalent number values. It's a good idea to get into a habit. Anytime you replace a variable with a number, you put it into parentheses, especially if you have a negative number, because how we evaluate this power is going to be a little different when this is negative inside the parentheses than if it was a negative without parentheses. So you really want to get in the habit of when you have a variable, put your number in for that variable, put it in parentheses. So now I'll start working through using my order of operations. First thing I would look at is the parentheses. So I have parentheses, but those parentheses, there's no operations to do inside of those, so I'll move on to exponents next. And I do have two exponents to simplify. First, I have a -3 to the second. Now what this is telling me is take this -3, multiply it out 2 times. So -3 times -3 is actually +9. Minus, I have a -1 raised to the second power. Again, this base -1 is being times 2 times. -1 times -1 is +1, so it's just a 1. Now I can continue. I'll do my multiplication next. 3 times 9 is 27. 27, it still has -1, so I'm left with the overall evaluated answer is 26. This will be my final result. Part B, I'm going to take my values for my variables and put them in for A and B. So here's what my problem would look like with 5 and -3 in for A and B. So again, I go through my order of operations. I'm looking for grouping symbols, and I see I have a parentheses around my 5, but there's no operations to do in there. Also around my -3, but there's nothing else to do inside those grouping symbols. But we do have a fraction. Fractions do work uniquely. Each numerator and denominator is thought of to have grouping symbols around it. So really, I do have a grouping symbol in my numerator. And if I had any other operations, that would be grouped together down in my denominator. So I have to work through the whole numerator first, and then I'll check to see if I can divide anything with the denominator. So now focused on my numerator, I'm going to look, I've already deciphered there's no parentheses in my numerator to simplify, so I move to exponents, and I do have a 5 to the second power, which would be 25. I've now got my 5 squared simplified to 25, and everything in my numerator is still grouped together, so I have to do everything up there first before I do anything with this -2. Now, it may be tempting right here, -3 plus 3 is 0. We could simplify that real quick using opposites like we talked about in lesson 1, but that would be out of the order of operations. So I first have to do my multiplying. So I will next take 25 times -3, and that's going to be -75. I'm now at the point where I just have one last step to do in my numerator, then I can start to divide by -2. So remember, everything in your numerator is grouped together, has to be completed first. So now I'll take -75 plus 3, and that'll move me back up towards 0 to -72. And then I have -72 divided by a -2. Anytime we take dividing two negatives, that'll be positive, and 72 divided by 2 is 36. So all of that evaluation should give me 36. In problem 3, I am going to use a calculator to evaluate. Before I use my calculator, though, I am going to put 4 in for m and p in for -2. One thing to notice on this problem is I am going to put a 4 into this exponent here for the m. So if m is an exponent, that just means replace m with this 4 right here. So you will see that when I start to replace each variable with its number. So now I've got each number in for its corresponding variable. So just to recap, here is my p, up here is my m, there's my m, and there's my p. So there I will see all those numbers put in for each variable. Now I'm going to take out my calculator and we'll start to evaluate using our calculator. So I'll bring up my calculator, and there is a tutorial on how to locate this calculator in the course information folder in Schoology. So if you need help locating this, please watch that video. Anyway, to evaluate this, you can also use your calculator. So your calculator will do the order of operations for you. So let's go through that. So we'll hit 5. Your parentheses is above the 8. Negative, you have to use this negative button. If you use the minus sign, it'll tell you that you have an error. So you have a -2. Now to raise to a power, we're going to use this caret button right here. Hit that, it'll open up a exponent. Now since you only have a 4, you don't have to put parentheses, you can just put the number 4. There's no other numbers inside those parentheses, so it doesn't matter if those parentheses are there or not. Now we're up in the exponent. To get out of that exponent, you have to arrow over. We'll open up another set of parentheses. So now I'm right here, open up parentheses, I'm going to go 6. Open up another set of parentheses for my value of 4, plus parentheses for my value of -2, and then I'm going to close off the parentheses around the outside of the 6 and the rest of that expression. Now calculator will do all of my operations for me, and if you typed it in similar to how I did, you should get 1,760. So I'll give you one more look at that. I'll bring my calculator back up so you can see that again, but there would be my key sequence to get 1,760, and if you need to, you can always rewind the video to check that out again. The second half of our learning target is we are going to take a look at combining like terms, and to do that we first have to talk about an algebraic expression. So algebraic expression are expressions that are separated by addition and subtraction symbols. So going back to your lemonade example, so you had 0.25, 25 cents per cup of lemonade. Well, maybe at your lemonade stand you were also selling apples, and you were selling those for 50 cents a piece. So your lemonade, you're getting 25 cents per cup. Your apples, you are selling for 50 cents per apple. And that would be your algebraic expression representing your profit for your cups of lemonade plus your your profit from the apples. So anything that's separated by this plus or minus sign, these are your separate terms of your expression, and the whole thing is representing a certain situation. Some variable expressions have terms with the exact same variables, and those are called like terms. So for example, if we had our cost of lemonade, 0.25, times the number of cups, and then maybe you're in business with your friend down the street and they're selling their lemonade for 75 cents per cup. Now this does relate to the distributive property. If you look, there is a common value of C in both of these. So this common value of C has been multiplied by both of these terms. We can rewrite this using the distributive property. This would be C times 0.25 plus 0.75. So if you were in business together, you're selling for 25 cents a cup. They're selling for 75 cents a cup. Your total profit then is $1 times the number of cups. So we can combine those together. This idea works for any like terms. You may also see like terms that have variables with powers. So if we have maybe a 3x squared plus a 4x squared, again, they have the exact same variable part, x squared and x squared. We can add those together to make 7x squared. So as long as they have the exact same variable part, we can combine those two terms together to make one term 7x squared. Lastly, we have constant terms. Constant terms are the terms that have no variables. They keep a constant value. If your algebraic expression has no constant, like this expression up here has no constant, then we would just say that the constant is 0. So I guess technically it always does have a constant. The constant would be 0. So in our first problem with combining like terms, we are going to look at this expression. This expression has 1, 2, 3, 4, has 5 total terms, and we are going to combine any of the like terms that we can. So looking at the variable parts, I have an MP right here, and then I also have a PM over here. Well, using the commutative property of multiplication, we could flip those two around, and then that would be MP. And this, since it's multiplication, those are still the exact same value. So now looking, that does make two of our terms alike, and I just like to either color code or using shape. So I'll circle 7MP, then I'll also circle plus 5MP. And to add those together, you're simply just adding the coefficients, the number parts of those variable expressions, 7 plus 5, which is going to be 12. Continuing to look through, we have a negative 2m here, but there is no other plain m variables to combine with the negative 2m, so negative 2m has nothing to combine with. Lastly, we do have two constant parts. We have an 8, which I'm going to try to make a box around, so using a little bit different shape, and then we have a negative 3. So now we will combine 7 and 5 to make 12MP. Negative 2 is going to stay the same, and then 8 and negative 3 combine to make 5. And then we'll rewrite our expression. So when all is said and done, we should have 12MP minus 2m plus 5. Lastly, we're going to look at the area of some sheet metal to combine like terms and figure out a total area of these pieces. So we're going to do two things. We're going to list the areas of the smallest 3 sheets of metal, and what is the sum of these sheets, and then what is the difference between the area of the larger sheet and the sum of the areas of the 3 smaller sheets. First thing we're going to do is going to find the area of each of these sheets of metal, and to find area of a rectangle, we are simply going to take length times width for each of these. So we'll do that first. We'll multiply our lengths and our widths together to find their total areas. So when I multiply out each area, I'm going to get 4x, 6x, 2x, and 15x. So when we are multiplying, we can multiply the two number values together if possible, and then the x is also going to multiply in as well when we find the area. So if we find the 3 smallest, we're just going to look for the 3 smallest x value numbers. That would be 2x, That would be a 4x. And that would be a 6x. And what is the sum? Since they're all x, we can add the numbers together. 2 plus 4 plus 6 is a total of 12x. Secondly, what is the difference between the larger sheet and the sum of the areas of the three smaller sheets? So big word here is difference. Difference is going to mean to subtract. So we'll take 15x minus 12x, and that is going to give us a difference of 3x. So there we have it. We've done our 2 learning targets today. We evaluated expressions using order of operations and also using our calculator. And secondly, we have started to discuss the concept of combining like terms. Thanks for joining, and now you're ready for your practice assignment. We'll see you next time.